Leaving cert higher level, paper 2, question 1. It's probability with 2 dice and a Bernoulli trial. So you're given this table and you're told that an experiment consists of throwing 2 fair dice and noting the sum of the numbers thrown. If the sum is 9 or greater, it's recorded as a win. If the sum is 8 or less, it's recorded as a loss. And you're given the W in this position here, 5, 6, and the loss in position 2, 1. So all the wins, 9 or greater, we have a 6 and a 4, 6 and a 3, 5 and a 3 to the left of that, no, 5 and a 4, 5 and a 5, 6 and a 5, so just work your way down. A 6 and a 4 is 10, 5 and 4 is 9, and then that will be 8, and then back here we have a 6 and 3. So these are all my wins. I'll put my losses in. We're asked to complete the table. It's a strange looking question for a leaving cert. You'd imagine this would be more of a junior cert question. So these are all losses. This is 8 or less, 5 and 3, 4 and 4, 5 and 3, 6 and 2. They are L's, not ticks. Does look like a correct L, L, and L. So that was part 1. Filling in all your boxes for wins and losses. We can see how many wins there are here over this side, and hopefully from your knowledge from junior cert you'll know the probability of all these. B part 1 asks for the probability of a win on one throw of the dice. Well, all probabilities are equally likely. 6 by 6 is 36, so there's 36 outcomes, and a win we have a row of 4, a row of 3, a row of 2, and a row of 1. 4, 3, 2, and 1 is 10. So that will be 10 out of 36 for the probability of a win. You don't get bonus marks for simplifying these down, but that will be 5 over 18. Part B, part 2, find the probability of 3 successive losses. The exact wording is find the probability that each of the 3 successive throws of the 2 dices result in a loss. And we're asked to give our answer to 4 decimal places. So the result of a loss, we can do it either with the 36 or the 18. So if 10 out of 36 is a win, it means that 26 out of 36 are losses. So the probability of a loss, followed by a loss, followed by a loss. All probabilities are equally likely. So it's just 26 over 36 to be cubed. Or you could say 13 over 18. We're just looking at the total outcomes here in the bottom, 36 each time. So just type this into your calculator. 26 over 36, or 13 over 18 to be cubed. And you're going to get to 4dp, 0.3767 to 4 decimal places. So part C is the Bernoulli trial. The experiment is repeated until a total of 3 wins occurs. Find a probability that the 3rd win occurs on the 10th throw. So 3rd win on 10th throw. So we're looking at the first 9 throws had 2 wins. So your 9 NCR2. By the probability of success to this number, we've had 2 of them. So the probability of success was 10 over 36 to the power of 2. We don't know whether it was on the 1st or 2nd, the 1st and 3rd and so on, and there's 9 NCR2 combinations of when it could be. And then the powers have to add up to this top number if you follow the pattern that you've learned in Bernoulli trials. So we have had 7 losses in this period if we've had 2 wins, and the probability of a loss from the previous part is 26 over 36. So that's the first 9 throws, but then on the 10th throw we multiply by what has happened on the 10th throw. We have had success, a 3rd win, so we multiply by 10 over 36. And on a calculator we're going to get 0.07908, 0.07908, and we're 4dp here, 4 decimal places, 1, 2, 3, 4, so it's 0.791. So Bernoulli trial question, easy when you know how to do it. Learn this process, learn the pattern of what happens in a Bernoulli trial. It's always the previous amount of throws to the one you're asked about, and the probability of success to this power, the probability of failure to the second power, that both add up to whatever number you have here. So an easy question to start off 2015 paper 2.